Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is tree transformation, and it is a medium level problem. So the problem itself was pretty interesting, but somehow Geeks for Geeks messed up with the test cases in this particular problem. So like before starting with the problem discussion, there's a few things that I wanted to mention. So I'll be regularly uploading Geeks for Geeks problem of the day and Code Forces contest tutorials, right? So if at any day you feel that I have not uploaded the video, then you can just check out my community tab. I always update my status there if I'm not available to record the video or when the video will be available, right? So all the information and all the updates are present there. And if there is no updates regarding the video and I've still not uploaded it, then I just request you to be patient. It might be coming out soon, right? So like today also, I just posted a post on the community page. So I don't know how many of you have seen it, but there I mentioned that I will be traveling in the morning. So that is why I wasn't able to shoot the video. Although I woke up early in the morning, I tried to do the problem in the morning itself, and I tried to shoot the video. But there were some wrong test cases in the problem, because of which I didn't shoot the video because I was not sure whether I was thinking wrong or the test cases were actually wrong. So later I figured out that the test cases were actually wrong, and now that I finally confirmed my solution, I'll be like explaining you guys what is the final approach of this problem. And one more thing, like we have already reached around like 995 subscribers, so that's a very good thing. I believe we're just a few subscribers away from 1,000, so that will be a great milestone to achieve. Let's just hit that very quickly. And also one thing, that today's video is very special as it will be the 100th video on this particular channel. So with this video we mark 100 uploads completed, which are publicly available on my channel. So let's just quickly start with the problem statement. So before starting this, let me just show you my submissions. So you see, like I made a submission in 2:12 in the morning, right? So I just woke up early and tried to like quickly create a video so that it is available for you guys in the morning. But it was wrong, and then I made a second submission. So this actually passed the test cases, but I still believe that the test cases were wrong because this solution was partially correct. According to me, it was not correct, and it was also only partially correct. Then I just left it the problem as it is, and like now I started solving the problem again. After a few rounds submission, I finally got an accepted word. So yeah, today's test cases were pretty weird. Now let us quickly start with the problem. Now this particular problem says that we have been given a tree, right? So this particular information is very important. I'll tell you in a while why is this important. So we have been given a tree with n nodes in the form of an array P, where Pi represents the parent of the ith node, right? So it's a basic tree definition. Now we have to find the minimum number of moves which is required to turn the tree into a star tree. Now they say the operation that we can perform is we can merge two adjacent nodes by deleting the edge between them and like combine them into a single node, right? And we have to form a star tree. A star tree is a tree with a center node, and all the other nodes are connected to the center node only, right? So this is our like two things that we know about the problem, that we can merge two adjacent nodes and combine them into one, and we have to finally form a star tree. And a star tree is a tree in which there is a center node and all the other nodes are directly connected to it. So all the nodes that are connected to the center node should not have any children for them, right? This is our problem. Now we have to find the minimum number of moves such that we can turn the given tree into a star tree, right? For example, let us take this example first. So this way I'll also explain you what is like how the sample input is given. So here we have it, and you see that we have been given the array -1 and 0 0 1 1. So this is the 0th index, this is first, this is second, this is third, this is fourth. So it means that 0 has no parent, it is -1, and the first index has parent 0 right here, right? So it will be attached like this. The second index has also parent 0, so it will be attached like this, right? Now the third index has parent 1, so it will be attached to 1. Another fourth index also has the parent 1, so it will be attached to 1 as well, right? So you see, this is how we are going to form a tree from the given input array. Now we have to find the minimum number of operations to convert the tree into a star tree. So in this particular case, what we can do is we can delete this particular edge. What will happen when we delete this edge? We combine 1 with 0. So 0 will remain as it is. Say this is 0 comma 1. I'm just writing it so that you know that it is combined, right? You don't have to actually write 0 comma 1. It's just showing that 0 and 1 are combined here in this particular node, right? Now it is connected to 3 directly, and it is connected to 4. It is connected to 2 as well, right? Now you see, this is the center node, and like each of the nodes is connected directly to it. In this particular case, if let us assume that this was the central node, and this was connected to it, but this particular node also had some further children. So this is not allowed. We can have one central node and we can have some children connected to it, but there should be no further extensions to it, right? This is our task. Now let me first explain you what was the wrong sample test case that I felt was wrong in the morning, and that was actually wrong. Geeks for Geeks team has now removed that particular case from the test set. So this case was the value of n was 4 and the values I believe were -1, 1, 2 and 2. So you see 0, 1, 2, 3. At the first index and at the second index, it is going to itself. So the parent of 1 is 1 and the parent of 2 is 2, which is obviously not possible in a tree, because it will make a self loop, right, which is not allowed in a tree. That is why I said that the definition that the given input will be a tree is very important, right? So like this sample, this test case was absolutely wrong. So that is something you need to note. This was in one of the test cases that you needed to pass in the morning. So that is why my code failed at first attempt, right? So now we will see an approach, and again I'll also tell you some test cases which were not there in the morning and which were later included. That is why I was saying that my second solution which got accepted was partially correct, and like that is why I didn't upload the video, because I wanted to because I just wanted to be sure. So there was some test cases that were not in the morning and that were included later. So I'll also explain you what were those test cases and how we can deal with it. So first of all, let us have a look at the general case. So let us see that we are just trying to form a tree, right? So first of all, let us just assume that this node, root node, is a central node, right? So how do we find out what is the minimum number of like operations to make this particular node or like make this particular tree a star tree, right? So you see that all these middle nodes, right? So if I even if I make the bigger tree, so let me just make a little bit bigger tree. So nodes will be like this, right? So this is a bigger tree than the previous one. Now you see all the middle nodes are absolutely unrequired, right? To make a star tree, there should be one node and all the other nodes should be directly attached to it, right? Like this. So if somehow I'm able to make these leaf nodes attached to this root node directly, then I believe that would make it a star tree. So let us try to find how many operations would I need to make this particular tree a star tree, assuming that this was the central node, right? So we are first assuming that the root node is going to be a central node, and then we are going to prove something which we'll see later on, right? So now let us discuss this first on a small example. So I discussed that the middle nodes are absolutely unnecessary. So what we'll try to do is we'll try to merge the middle node into the root node, right? So once we try to merge this, now in this particular case, these four nodes will be directly connected to the root node now, right? So this becomes a star tree, right? So this required one operation, right? So now what in this particular case, you will see that first of all, we will need to remove this edge and this edge. Now this root node or the center node will be connected to two nodes like this, and then again two nodes like this, and these two nodes further have some extensions, right? Right. And then like in this case you remove two edges, right? Also I'm sorry, in this particular case also the answer will be 2, right? So the answer will be 2. Why? Because you were removing one edge from here and one edge from here, right? So in this case, still now you have removed two edges. Now you have to remove this particular edge, this particular edge, this particular edge, and this particular edge, in a total of 2 plus 4, right? So now these leaf nodes will be directly connected to the central node. This is how we can try to form a star tree once we have assumed that this is going to be our center node, right? Now let us see something very interesting about this tree. So this was the initial tree, let's say, right? So we have 4 leaf elements, right? Now let's say this was the initial center node that I was assuming. Now I want to make this particular node a center node, right? So if I make this particular node a center node, it has 3 children. So let's say one children is this, second children is this, third children is this, right? So now this particular node has become the central node or the root node, let's say, right? So the third one is this, then we have one node here and then 2 nodes here, right? So the number of leaf nodes in this particular case was equals to 4, and in this case also you will see that there are only 4 leaf nodes, right? So the number of leaf nodes did not change no matter where we shift our center node to, right? Or where we start our DFS from, or where we like mark the root node as, right? So the number of leaf nodes does not change. So how this property helpful for us? You will see that the number of operations that we need to find to make the node into a star node will be dependent on the number of leaf nodes. So if the number of leaf nodes are fixed, no matter which node we assume as the center node, we will always be able to find the correct answer according to the number of leaf nodes, right? So how does this like particular number of leaf node help us? So you saw in these two previous examples, in this one also, in this one also, like, right? So these were the leaf nodes, right? These were the leaf nodes, and the edges with the leaf nodes were not removed, and all the other edges. So this edge is not with the leaf node, this edge is not with the leaf node, this edge, this edge, this edge, and this edge, right? These 6 edges which were not with the leaf node were removed, and all the edges which were present with the leaf node were kept intact, right? So this is what we have observed till now. So the number of edges associated with the leaf nodes will be obviously equal to the number of leaf nodes, right? Right. And these are the edges that we need to keep intact, right? So all the other edges we will be removing. What are the total number of edges in a tree? It is equals to n minus 1, right? These are the number of edges we need to keep intact. So if we subtract it from the total number of edges, we will get the number of edges that we want to remove, right? So this is the final approach of this particular problem. Let me just quickly summarize this part first, and then I'll explain you something very interesting further, right? So what we have observed till now, the first thing is, whenever we form a tree, right, either this one or this one, right? So if we want to convert the tree into a star tree, we find a suitable way to attach the leaf nodes directly to the central node, right? So if we want to attach the leaf nodes to the central node, then we wanted to find out, does our central node or the change in the central node changes the number of leaf nodes or not. So we like just checked it in a way that if we change the central node, the number of leaf nodes does not change, right? So no matter which one is the central node, the number of leaf nodes will remain the same. Then we tried to find out how is our answer depending on the number of leaf nodes, right? So we found out that the edges associated with the leaf nodes were not removed, and all the other edges were removed. So the number of edges associated with the leaf nodes are equal to the number of leaf nodes. N minus 1 is the total number of edges. If we subtract number of leaf nodes or the number of edges associated with the leaf nodes with it, so we will get the number of edges that we want to remove, right? So this part is very clear. Our answer will be equal to this value. Now there were certain cases that were not included in the modeling test cases, right? And they were included later on, right? So that is why I said, and I'm repeating it again, that in the morning I felt like my problem was like the solution was partially correct, and that is why I didn't upload the video. I just stopped there. I had the plan to upload the video, that is why I woke up early, but I ended up not uploading it just because I wanted to be sure on this particular part. So the last part of this particular problem was, right, let's say we have an example like this, right, or any similar example where we have the root node or the central node like this. There is only one children attached to it, and there might be any number of children now like this, right? So according to our algorithm, what we were trying to do is, we were trying to attach these particular leaf nodes to this particular center node, right? So it was a valid way and it was working till now. But you see that there is no need to attach to this particular node now. Why? Because if we try to attach these nodes directly to this particular node, then also our tree will be a star tree. I'll show you how. If we remove this particular edge and this particular edge, our tree will look like something like this. So we have this particular node here, and it has 4 children downwards. So it is equals to like this, and we have one parent, right? So you see it is still satisfying the property of a star tree, right? So in case the number of the number of children of the root node or the 0th node is exactly equals to 1, then our answer will be this particular value that we have found, minus 1. Why? Because there is one more edge that we don't want to delete now, right? And that would be this particular edge. In all other cases, what we were trying to do is, we were trying to merge these leaf nodes directly into the root node, but that is not the case now. It is not actually required. We can just save one more edge by just attaching all the root nodes to the first children of the root node, right? And this is only possible when there is exactly one child of the root node, right? In all the other cases, answer will be this particular value, n minus 1 minus number of leaf nodes, and in case the number of children of the root node is exactly equals to 1, in that case answer will be this particular value, minus 1, right? So this would be the solution of today's problem of the day. Now let me just show you in the code how I implemented this problem. So I created a vector called out. So this will be storing the out degree of every node. What do I like? Why do I need to store the out degree? So you know that in a tree, if the out degree of any particular node is 0, that means it is going to be a leaf node, because there are no other nodes arising from it, right? So for all the values, what I am doing is, I am not taking the 0th node because its value will be minus 1, right? and for all the other values p of I will be its parent, right? So 0 will have its out degree incremented by 1, right? So it is going like this. I'm incrementing the out degree of all the nodes. Now I initialize my answer with 0, and for all values from 0 to less than n, or basically through the whole array, I'm just counting the number of leaf nodes. So if out degree of I is equals to 0, that means it is a leaf node, and I increment my answer with 1. And at the end, if the out degree of 0 is also equals to 1, that means the root node has only one children, or exactly one children. In that case, I'll increment my answer. So why am I incrementing my answer? Because at the end, I'm subtracting one answer from my answer from some value. Sorry. So this is going in subtraction. So basically, I'm subtracting -1 from that particular value. So let me just also show you. So I could have also written it as n minus 1 minus answer minus 1, right? In this particular case, when out degree of 0 is equals to 1. But instead of writing it, I just incremented the answer. So it's basically like this, answer plus 1. So this value is essentially going to be the same, right? So this is what I did right here. So this was it for today's video. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video. And don't forget to subscribe to this channel. It's always free of cost, and you can always subscribe later if you don't find the videos interesting. And like I see a lot of people who watch these videos have not subscribed yet. So if you're one of them, definitely consider subscribing to this channel. We're already like very close to 1,000 subscribers. So let's just do it quickly. And till the next video drops, keep sharing this channel with your friends. Keep coding. Stay safe. Bye bye.